Hi everyone, I'm Guan Yao. This is today's topic. I would like to show you what Lumerical can do, and an AR simulation example for design of an optimal diffraction grating. Before I start, let me briefly introduce our group company. Cybernet Malaysia is a full-owned subsidiary of Cybernet System Company, Limited headquartered in Tokyo, Japan. Established 37 years ago in 1985. Cybernet's partnership with Ansys also has a long history. We have sales subsidiaries also in China and Taiwan. You may have heard about Sigmatrix, MapleSoft, and Noises Solutions. They are also actually a part of the Cybernet group. Cybernet System Malaysia supports customers in Asian region. We are a channel partner of Ansys in those countries. Cybernet System Malaysia specializes in computer-aided engineering solutions, digital transformation, and we also provide engineering service, training, and consultation in those domains. Ansys multi-physics platform consists of structures, fluids, electronics for many years. In the past 2 years, optical and photonics software were added to allow the platform to simulate more aspects, include spheres, Zemax, and Lumerical. Lumerical is for simulation of photonics. One can use Lumerical to simulate about wave optics, radio frequency, electronic optics semiconductor elements that, in most of the system design workflow, Lumerical can design the micro or nanoscale structural component and output results as component specs for overall system. In some workflows, users need to match 2 or more components from different software. You can use the OptiSLAM platform and script to control each software and fine-tune the components. Let's go back to Lumerical. When we need Lumerical, let us take optical simulation as an example. When the size of the structure is close to the wavelength, there will be interference and diffraction phenomena. At this point, it is not suitable for describe wave propagation behavior by Snell's law only. Although wave optics can also obtain the results of geometric optics, it is efficient. Therefore, as mentioned above, we recommend use Lumerical to microstructure simulation, but when there are larger components in the system, co-simulation with other software is more efficient. A system may have components of different size order, and the system may interact with the environment. For example, the reversing assistance system in the picture on the right. The size of the lens group is about several millimeters. Each pixel of the CMOS is several microns, and the pixel size of the display is several tens of microns. Zemax is recommended to optimize the lens set. The crosstalk phenomena of CMOS and the luminous behavior of the display are suggested to be analyzed by Lumerical. With Zemax and Lumerical, you can get some values as the results, such as system MTF, color shift. If you want to see more complete results, such as the final image of the display signal superimposed with glare, the feeling of blur, where the color difference is perceived, it is recommended to further use spheres. Spheres is good at rendering intensity and spectral information into human vision effects, so it is highly recommended to have these 3 at the same time for a more complete optical simulation. Let's talk a little bit about Lumerical. There are 4 simulation models in Lumerical, of which the FDTD, mode, and multi-physics models are for component-level simulations, and the interconnect is for simulation of photonics integrated circuit system. Scripts are used to assign in data transfer, modeling, and adding calculation conversions and drawing chart effects. Component simulation models are classified according to different calculation methods. Next, I will going to introduce each model one by one. FTDD uses the finite difference time domain method, which cuts the structure into sub-wavelength scale qubit elements, and calculates the boundary conditions for each qubit with the Maxwell equation. Any structure and source type can be used to calculate its optical properties, such as its transmission percentage, bidirectional scattering distribution function, spectrum reflected by the device exact. However, the simulation time of the FDT simulation is relatively long, and it requires larger computing memory. Therefore, for spatial structure, such as periodic or uniform stack, we import rigorous coupled wave analysis and thin-film matrix analysis method in the form of pre-written script functions to speed up the simulation. The mode module mainly uses the eigen-mode method to simulate various optical communication components. It will give the spec like effective index, loss, exact. The eigen-mode method concept is to find standing waves that can exist in resonant structures. It can be calculated by analyzing the cross-section of the structure, which means that only 2D simulations are required. So it is much faster than FDTD method. Although the eigenmode expansion method needs to analyze multiple sections and then compare the coefficients, the computational complex is much less than FDTD method. When the shape is more complex, the concept of FDTD is still needed. The VAR FDTD module makes some simplifications in the material index, which leads to some shape constraints, but it has an advantage of being faster than general FDTD. To briefly summarize that we discussed so far, Lumerical provides FDTD module which can do optical simulation of any structure, but the disadvantage is that it is more time-consuming and memory-consuming. In addition to the FDTD method, Lumerical also provides some other analytical method to speed up the simulation. The multi-physics model uses the finite element method, so it can do electrical, thermal, and optical simulation in one model. The FEM method uses the tetrahedron as the cutting unit, which can fit the surface structure better than the FDTD method. However, compared with the FDTD method, it consumes more memory, and the setting is more complicated. Therefore, the FDTD modules is recommended for optical simulations. Multi-physics here is for characteristics of micro-sized components. For example, to design a traveling wave Mach-Zehnder modulator, it is necessary to simulate the modulation curve of the carrier density to the effective index, optical and ratio frequency modes in fiber. There are also characteristic parameters of the structure, such as the capacitance and reactance, which needs to be brought into the circuit system simulation. After designing the components, Lumerical provides a system simulation interface such as SPICE, called interconnect. Both the optical and electrical signals can be included, which is called photonic integrated circuit or silicon photonics. The designed component characteristics can be imported in the surface, and some components models are also provided to facilitate users to create small integrated circuits. There are also analysis groups that facilitate analysis of device or integrated circuit, like I-diagram. The process of photonic integrated circuit is the same as that of semiconductor circuits, so interconnect and fabrication-related software, such as Candida's layout and analysis interface, have a convenient cascading workflow. Let's look at a code simulation example of Lumerical and Zemax. Here's the workflow for designing an AR system. Lumerical needs to find the grating structure that matches the target, and give the corresponding light field of the grating under various conditions of the incident light. The picture on the left is an AR glasses concept. In order to make the AR glasses thinner and lighter, the system chooses grating as component instead of prism or mirror to change the direction of light. Because the size of slab waveguide and grating are very different, it is more efficient to choose geometric and wave optic simulation respectively. In this example, we have to think of the design goals in terms of grating parameters, such as how many orders of diffraction are there, what is the design wavelength exact. The angle between the diffraction orders is determined by the wavelength and the period of the structure. The energy distribution of each order is related to the shape of the grating element. Therefore, to optimize efficiency, the shape must be parameterized, such as vertex coordinates. Lumerical's optimization method is particle swarm optimization. In the optimization interface, after setting the parameter, you can specify a certain simulation result or a formula formed by a combination of simulation results as a design target. It is a very useful analysis tool. After optimization, in the design wavelength range, the reflected energy is mainly concentrated in the -1 order. The light from the sun also has a good transmission. There is a beta version of the script functions used to facilitate grating information to Zemax. The input items include the project of the structure, the material, and the required light incident conditions. This function will output a JSON file with the information Zemax needs to define the grating. The JSON format is not specifically used by Zemax. It is an output format from Lumerical. In Lumerical, JSON relay script functions allow us to easily write data into text files. The JSON format makes it easier for Lumerical to co-simulate with any software. Taking Zemax as an example, for grating, Zemax needs to know the items on the left. The image on the right is a JSON file format that Zemax requires for grating. JSON file will be imported by DLL plugin into Surface, because there is still some computing work after importing to Zemax. Zemax has some requirements for grating JSON files, such as name rules, directory paths, etc. Grating in Zemax needs to be set on the surface of an object, because grating simulations are time-consuming in wave optic simulations, and greatly increase the number of rays in geometric optic simulations. So, the incident light from different size fields are split into two files, in order to simplify the model depending on the situation. Grating properties can be built on three types of objects. There are diffraction gratings, and two types of user-defined objects. Different software may have different post-processing for import files. In the case of file transfer between Lumerical and Zemax, we have confirmed that the values of the files in the two software are the same. After completing the above steps, we have successfully expanded the component in Zemax and can start system simulation and evaluation. In Zemax, the input optical signal, the length group, and the uniformity of the image seen by the eye are simulated. Of course, this system needs further fine-tune and correction. Okay, this is the end of today's sharing. If you have any questions, please feel free to let us discuss.